how the block being splitted. So what Hadoop takes care of in terms of extreme disaster issues, failure issues, those we are seeing, right? So that's pretty much about the Hadoop. So if you want to recollect the services or daemons participating in the HDFS, predominantly we have name node and data node. So there will be only one data name node in the cluster, and there will be multiple number of data nodes will be one in each of the participating slave nodes. So this is the architecture you have seen it. Now we will move on to the next framework in the Hadoop, that is the Mapreduce. So Sharada or Raj, anyone of you have questions? Rajiv, on the earlier discussion?
Not so far, nothing.
Okay.
Nothing now.
Okay. So if you look at the stack again, we have discussed so far the file system. This is the core platform in the Hadoop, and the next one is the Mapreduce. This is the execute engine or the runtime engine. So whatever the programs we run on top of Hadoop, they take benefit of the HDFS, not on the local file system of a given data node. So all the programs what we write in Mapreduce, they work against the HDFS. So let us see the stack topology here. So in the Mapreduce, predominantly we have two sets of daemons. One is the job tracker, second one is the task tracker. Just like what we see in HDFS, there are predominantly two categories of daemons. One is the master daemon, and second is the slave daemons. Similarly, in Mapreduce layer, you have job tracker daemon and the task tracker daemon. So there will be only one job tracker in the entire cluster, and task tracker will be one per each node, right? So in other words, if you want to see the picture, this it would look like this. So in a cluster, we have a name node. There will be a job tracker in the one of the main servers, and if you come down to the slave node level, we have data node, and there will be a task tracker. These two are the primary daemons running inside a slave node, one per each slave node. But there will be only one name node and one job tracker inside a cluster. And also you see maps, reduces. These are the slots. I'll come back to you when the discussion comes. But please understand this one. We have only one task tracker for each node, and there will be only one job tracker for the entire cluster. Right. Let us look at the high-level semantics. I'll close this one. The same thing. So let us see the Mapreduce the theoretical point of view. So primarily in the Mapreduce programming model, the architecture, we have two sets of things. One is the maps, other one is the reduce. So what is the concept behind map and reduce? The syntax, you could see it here. Everything goes by the key value combination here. The input is a key value, the output is a key value. Even in the reducing world also, input is a key value, of course list of values, and the output is a key value. Everything is key value based orientation here. So essentially, if you want to look at the idea behind the Mapreduce, here we are trying to deal with the huge files, and the file is a scattered one. It's not in a single location, right? So if you look at the file, the kind of files you are dealing with these are the files, those are scattered across various nodes as per the HDFS. And those files processing needs a different methodology. They are not like regular files where you can open file. You can't even open a file for reading that much big files. So let us say if you have a small text file in your PC, you could open and see the content there. But with these files, you can't even imagine to open the files. Such a big files, you're dealing with that. So you should have a different methodology to deal with this. Otherwise, even the existing infrastructures, existing highly available RAM, highly available processing power also cannot deal with this kind of files with the volume we have.
How much
So
volume
let us
you said?
volume. I mean to say the sizes.
Yeah, oh, okay.
Volume. I mean to say sizes means you're dealing with a file that is beyond 30 GB, 40 GB file. Each file.
Yeah.
That is the volume. So that files you can't even afford to open the file and read the few lines of the file. That also you can't see. Such a big files, and there's no proper methodology to do that. Simply system hangs if you do something. So the approach is that it will be in two phases. One is that do a primary analysis, primary processing of the file, so that in the primary process called step 1, you want to collect or mostly divide it basically. Divide the input as much as possible so that this output from the phase 1 will become input to the phase 2. And finally, in the phase 2, mostly it's like a regular programming model. Basically you'll be doing sorting, filtering, those things. And finally, at the end of the phase 2, you get the output here. But the main heavy lifting will be done in the phase 1, where you look at the entire file, length and breadth of the file, and try to crunch it as much as possible so that in the phase 2, you could easily refine them using known techniques like sorting, filtering, those things. This is what it is all about at Mapreduce. In the mapping phase, you try to map the file to a given programming scope, given algorithm scope. You try to map it. So during that mapping phase, our written algorithm or written code will try to reduce the file size to an extent that we can process the file subsequently with the known techniques like sorting, filtering. That's what in computer world, right? Computer world is famous for what? Sorting and filtering predominantly. So to get to that point of you should be able to sort or filter, you should reduce the size of 30 GB to 1 GB. That's what the actual input, the refined output you need. But to get to the 1 GB, you have to process the whole length and breadth of the file. Then only you come to know you only need 1 GB out of it. So that is the kind of the crunching going to happen in the map files. So everything goes by the map and reduce cycles, and the syntax is that everything is by the key and value pair combination. It could be like a collection of values, but there will be a key and value combination you see everywhere. So what is the need for key and value? The real need of why someone has to go with a key and value approach. Why can't we have something other? Why can't we just have collection of values? The reason is that we are talking about a distributed world where the problem is that there are so many machines participating in it. So if you want to get a unique
key is like a primary key, right?
That's correct.
Okay. And the value is the rest of the value.
Value. Key Um,
Value is the
key,
actual data.
Yeah.
yeah. So let us not completely correlate the key with the primary key. Primary key in the database world, the meaning is different. It's a unique key across all the data set. Whereas in the Mapreduce world, key just identifier. It need not to be a unique one. Are you getting the point here? Key is a identifier, but doesn't necessarily be a unique one.
Yeah.
So typically like this, in the programming, let's say if you are a Java based or some other technology based developer, if you have any exposure like that, you would be dealing with the hash tables, hash collections. There, the concept is the key and value. There, the key will be unique. Whereas in the Hadoop world, key and value are existing to identify a certain thing, not necessarily be unique, their combination. So why that is so, we'll come to know in a minute. Okay. So the point I'm trying to bring in here is that the key, the structure is required because we're dealing with a distributed computation here. Because so many task trackers would be involved in crunching the file. So there should be a correlation among these individual task trackers. And finally, someone should be able to assimilate all the work being done in each of the task tracker. How does the assimilation happens? This assimilation happens through some mechanism called key. As long as you're running in a single box, key might not be much significant for you. But when the time comes to collect all the outputs from individual task trackers, in that assimilation, you should have a different approach, deal with the uniqueness, or to sort and filter it like that. So don't worry if you're not getting the point. We'll come to know.
So as a Hadoop developer, right? How is this key and value going to help us?
Yeah, I'm coming back to that. But I'm just want to give a theoretical awareness about map and reduce. The significance of key you will come to know. Just a minute. Okay. So now you could see some visualization about key and value here. So typically, if you look at a file will have multiple lines. So in the Hadoop world, how this is going to work is that when someone joined now.
I only joined.
Okay. So key part it will take some time to understand how the key and value have a significant importance in this framework. But let us see how a typical file being processed. Then you'll get insight about key importance. So typically in the Hadoop world, let us say we have millions of lines or billions of lines in a huge file. So when we develop a program in the Mapreduce, what typically is going to happen? Each line will be splitted by the input split here, and each line would go to a task tracker. The maps are like let us put some content here. The maps are the small execution slots residing in task tracker. We have two sets of things. One is job tracker, second one is task tracker. Job tracker is a master controller of the Mapreduce program, whereas task tracker is the individual executing engine who contribute to the job tracker. Similarly, what we have seen in the earlier, maybe I should put it one more slide. Give me a second. Should have this slide clarify your understanding. Okay, this would give a clarity to you what we are discussing now. Yeah, so just to want to catch up the words here, in the Mapreduce framework, it works in conjunction with the HDFS. There is no place for the Mapreduce framework without HDFS. So, in this world, what you see, there is a job tracker as a master controller of the programming model, and there are independent task trackers. But task tracker is purely the local coordinator of the programs what we develop. But there should be some arrangement to run the program. That arrangement is called the slots, the map slot and reduce the slot. What does it mean, map slot and reduce the slot? The slot is like a dedicated activity where you can pump in the map based program. Reduce is a exclusive slot where you can pump in reduce activity. What does that activity? I'll just come to in a minute. But for now, please remember, understand to this extent that there is a controller at a local level called task tracker that will be in complete touch with the job tracker. When we submit a job to process some big file, what does it happens is that job tracker splits the program into tiny packets, and each packet would go to individual task tracker here. Now the program has been distributed, but who actually executes it? The execution task tracker take help of either map or either reducer. Either map or reducer. So this is the stack model.
And your job
right?
can be anything like a select star from or anything like that, right?
Anything like that. But there is a certain framework structure you need to follow, but that could be anything.
Yeah.
But select star from is a SQL oriented aspect.
Yeah, but this will be LSLTR or something like that for the or cat.
Yeah. Imagine that anything could be, let us define anything here. You are dealing with a file. You're not dealing with a table, you're not dealing with anything.
Right.
There's no structure for it. That structure is your own structure. It could be a comma separated file, it could be binary file, it could be anything. You only aware of the file structure, right?
Yeah.
That's not a universal standard. You're not going to follow it. So you are going to work with a file. You might know the structure of it. So what kind of activities you could do? Maybe you could read a line and process a file, or you could apply some regex patterns on it, right?
Yes.
Do some regex extractions of it, or you could find some meaning in that line. So line by line you do processing typically. That's how you do. So what essentially you could do in a file, open up a file, read a file, extract the content or split the content. Those things only you could do. Select star from is a much more abstracted thing, where you know for sure the underneath source is a table, but here the source is not table, it's a flat file, simple file, right? Yeah. So are you all clear about this topology here? How this is going to work, I'm explaining that in a minute. Clear? There is a task tracker at a local data at a individual node level that takes care of the tiny packet of processing. So task tracker is a kind of a administrator locally, job tracker administrator globally, and there are map slots and reduce slots. Slot is like your dedicated piece of processing. Say you have a 16 GB RAM in a server. So the 16 GB RAM could have been divided into 16 GB RAM, and there is a 4 core processor in a server. So the combination of these two would give around 8 map slots or 8 reduce slots. That means the task tracker can run 8 parallel map tasks, 8 parallel reduce tasks. So that is the arrangement basically we are looking at it. So yeah, let us look at the framework in working. Then you can correlate to what I'm talking. Okay. So we have a huge collection of lines. So when we develop a program to process it, basically let us say we want to process the whole file and see yeah, take example of temperature. The meteorological department, they record temperature at various locations in US. So it says that location A has this temperature, location B has temperature. But our objective is to, across the 30 GB file, millions of rows, we want to find out the top 10 max temperatures recorded on a particular day. So what essentially you have to do, first thing is that you have to extract the temperature reading. That won't be a simple line. There's a big line out there. Somewhere at some location, the temperature reading would be there. And somewhere at this point, you have the date and time. So essentially, you have to pick up this location. You have to pick up the location. And finally, you have to do max of it, top 10. So out of millions of billions of rows, you have to collect these values. And finally, you have to do a sorting and then filter it on the topmost 5 readings in this. If that is the objective you're looking at it, essentially what you have to do, first thing is that you have to extract these two fields from a single line. That's what we're going to do. So when we send when you develop a program, the program will split the file into each line. So each line will go into the splitting algorithm here. So we don't write the program to split the algorithm. We only say, let us split it by line character. That is the most default thing in any of the file, most of the file. So that only we mention it. So the Mapreduce framework will take care of how to split the file. So what it does during splitting, each line would go to mapper task. So mapper task, it sends each line to mapper task here. So in the mapper task, you write your custom code. That's all your custom code, because this is not a framework stuff. You only know the structure of the line. So now you write a code saying that at this location A, my year value is there, and location B, I mean to say position. Let's say the character position 10, I have the date. At character position 100, I have the temperature. You read the length here from 10 to 20, that is my date value. From 100 to 102, hardly will have 2-digit temperature. 102, I will have temperature reading. Extract the 2 lines. That code you write it here. That's a custom code. That's only you do. But how that line got to the map, that's all the framework responsibility. But framework will ensure that you get a single line in each of the map tasks. So inside the map task, you write your custom code. Now, the output of the map task again, key and value pair, right? So now what you have to do, now you got the temperature, key is our date. Imagine that we have a date, and value is the required thing. What is the objective we need? Out of all dates, so out of all values, we want to get top 5. And also we want to filter it on the date. So here in the first level itself, you eliminate the key based on the date criteria you have. Let's say if you're processing today, this file could have all the 1 month data. So you don't even generate a key value which is not when the date is not matching to your requirement. You ignore all the keys. Only you dump the keys with matches the today's date. Now you get a set of keys. They're only for the today's state. Now, second thing is that you will have value things here. So now in the value phase, now you have to see, you have to find out a max values here, right? Max temperatures here. How do you do the max? Either you do a for loop kind of thing, iterate to all the values, or quickly sort it. That is the one mechanism, right? The algorithmic way is that quickly sort it. In the sorting, if you sort it by ascending order, the top 5 records will be the answer for you. You don't have to check whether value A is greater than or less than B, B is less than equal to C. That thing you don't have to do. If you can sort the values quickly, the sorting itself will give you the top 5 records. So that is the approach this is going to take. So what is happening now is that each line, the file has been split into multiple lines. Each line went to map. Here you extracted the temperature, but you don't know at this point that this is the max or minimum. You don't know. So there is a combination phase called combiner here, and then sorting phase here. So what it does, these two phases collect all the keys from the maps and they combine it and say whether are you looking at duplicate key or are you working with the same key. If it is duplicate, you'll ignore it. So that kind of combination it do. Combining part it does. And then now it has time to sort them. Once you're able to sort it, the reducer job, here you write a custom code here. And these two are automatic. You don't have to do anything. These are framework given thing. You write custom code at this mapper level and you write custom code at the reducer level. At this code, what code you have to write? What you will have a sorted list of key value pairs. What exactly you have to do? Only pull first 5 records. That's it, right? Is it a big challenge for you? No. So all the heavy lifting is done by the framework. Splitting up the file done by the framework. Only thing is you have to extract the fields. That anyhow, because you are the owner of the file, you would be knowing the file structure, file schema. So that you have to do. So that part you do. But once you pick up the values from the file line, the merging and sorting is done automatically. So all that you have to do, now you got refined output here. From the refined output, you have to process the output and get the required result for you. What result you need? You need top 5 temperature readings on a day. That quickly you can do. Not a big thing. Simply a simple Java program to determine top 5 records you can do. So this is the heavy lifting part in the Mapreduce. Okay, so let us take example of a simple program, how it going to work. You might be hearing about this thing again and again in various lectures or various seminars, but I want to take a classic example like hello world program and see. Any questions you want? We'll discuss it some more time now, but I want to pause for a second now. You have any question? Are you all with me?
Yeah.
Okay. So let us look at the same thing in a different way. So now, when you develop a Mapreduce program, the file splitting is done by automatic. The origins are automatic file. So each split, each line, essential line, right? But in the terminology being used as split. Each split will be passed on to the mapper code. This is your custom code, the blue one.
Unless we compopulate it to something.
Someone has a question? Someone has a question? No?
No.
Okay. So in the mapper phase, you write your custom code. Now the time comes, you generate the key and value pairs here in the mapper phase. So now the sorting will be done by the framework, the white box. So when the sorting is done, now even the output from the sort itself is millions of keys. billions of keys, could be like that. Such a high data set we're dealing with this. So the crunching should happen. Otherwise, there is no pointing in dealing with this kind of infrastructure. This is where the crunching happens. So the sorted items, the sorting happens locally. It's not a global sorting. You please understand this one. This local sort happens. So each local sorted output would come down to merging places here. At these merging places, one more level of filtering and sorting happens here. This is the merging phase here. Now, from the hundreds of mapper tasks, we came to tens of reducers here. That the crunching happens now. And in the reducer phase, you write your custom code, and finally the reducer will produce output. And there is no assimilation of all the data. Each reducer produces its own file. You see file as part 1, part 2, part 3. It doesn't combine all the things in a single output. It is your responsibility to combine all the output. But one thing is sure that the output structure would be same in all of the part files here. Right. Let us look at an example, then you will get clarity what you are talking about. Yeah, by the way, have you downloaded the Eclipse?
Yes.
Raj, Sarda? I know Rajiv
Nobody.
was downloaded.
No, I didn't
Sharda?
download it.
Oh, please
I
do
didn't
that.
know.
Tomorrow we need that Eclipse.
Okay.
We run some hands-on with the Mapreduce.
Okay.
Rajiv, Raj, if you haven't downloaded, please have it by tomorrow. Okay. So there is.
Madhu, just a quick question. So the extent of this SSH tool, right, empty is only querying, only doing Unix stuff, right? So when we get to Eclipse, it's more of Java coding, right?
Yeah, that's correct.
And
So
you
the
said,
putty not just for the not only for the Unix stuff. That is like a terminal to do any activity. It could be file accessing, or it could be running a Mapreduce job. But you develop a Mapreduce job in Eclipse, but running would happen from the putty.
Yes. Okay, but you said we don't have to have a lot of Java background for Eclipse. I mean, to
Yeah,
do
we
that.
don't need. See, that's what you see it, right? See, this is a complex architecture. But what essentially you're doing it here? Are you working on the splitting? No, it's all automatic.
Yeah.
You just have to tell the architect framework that what the splitting algorithm. Is it by line or by length? What is that? That's only you have to mention. All that code you write is that mapper code here. And then you write reduce code. These in between things are automatic.
Okay, the mapper code is in Eclipse, right?
Yeah. So blue ones are only you will deal with this.
Okay.
This picture will show you this. These blue ones are only you write it. You write a mapper code and you write reducer code.
The reduce code
sorting
is where? SSH tool, empty putty?
Could you repeat that?
Where do you write the SSH code? Sorry, the reduce code?
Yeah, that's in the Eclipse.
Oh, both in Eclipse, okay.
Eclipse, yeah. There is a structure you have to follow when you are writing, when you're developing the Mapreduce programs. But this slide basically should give an insight to you. Only this is the complex one, no doubt. You're dealing with huge things, a lot of things are involved in this thing. But among all, your responsibility, the kind of activity you do only at a map, writing a map code and reducer code. That's it. Rest of all automatic.
Okay.
So look at this thing. Only 30% are you dealing with this. Remaining 70% is automatic by the framework.
Yeah.
Right? So that's where I say You don't need to have a very niche, very deep knowledge about Java. If you have high-level Java understanding, some OOPS concepts, that is fine. But even now, Mapreduce is becoming kind of a classic thing. It is a theoretical, in most of the cases, you don't really work with Mapreduce. You don't need to, unless you have a very peculiar challenge that can't be solved with any existing frameworks. Only you get into the Mapreduce. Mapreduce is like a C programming. How many times in your career you worked with a C or C++? Unless you are a core product development engineer, if you completely dedicate to developing new products, there is no such need, right? See, for all line of businesses, do you go for C++ or Java or .NET?
No.
You go for abstracted programming, abstraction, high-level programming layers, right? Like Java or .NET. They does a lot of abstraction on the file system, the processing, parallelism, those things. So Mapreduce is like you can correlate this this idea. Yes, Mapreduce is written in Java. That's correct. But the Mapreduce style, Mapreduce assignment needed only when you have no other alternative to process a file. But this is essential to understand because later you will come down to the Hive and Pig. Those are very fantastic tools. You will really love it because that's why that will be very close to your understanding. I mean to say, apologies if I'm using a wrong word here. That is very close to your known area. I mean to say, if you should be familiar with the SQL. You should have been familiar with simple scripting language like shell scripting or the MS-DOS scripting or Python-based scripting. If you are familiar with any of the scripting world, you love Pig. If you are if you love the SQL-based queries, you love Hive. But how those things are working? Because you are predominantly what you're doing is that in Hadoop world, you're trying to process a file. That file of no standard, right? You only know the file format. It's not a universal standard file you're dealing with this, right? But whereas in database world, there is stand out there. There is a normalization, universally accepted normalization techniques are there. There is a defined structure given by the database vendor. Those all the things are taken care. But in Hadoop world, there is no structure at all. You put a file and then you're trying to query on the file like a SQL table. That is the level of simplicity the Hive and Pig is going to give. But the simplicity will have some heavy lifting. That heavy lifting is done by the Mapreduce. So once you come to the Hive and Pig, you will be relaxed and you'll be relaxed to know that the Mapreduce is not completely required all the time. That's what I'm trying to say. It is good to understand the framework, and given a need, having a need, you should be getting to the Mapreduce coding level. That's what this slide and the subsequent slide is going to give you, right? And you should be aware of it. Otherwise, when time comes, when you have to develop a Mapreduce program, you should not be feeling like inefficient with this. Okay. All right. Let us move on and see the things in Mapreduce. Rajiv, are you with me?
Yeah.
Yeah. So, just recap of things. Job tracker is the master controller of all jobs. Why are you calling the job? So, in Mapreduce world, this is not interactive. If you recollect the earlier intro sessions, in Hadoop intro session, Mapreduce is not a interactive one. What does it mean? If in a SQL world, in Oracle world, or if you are developing a Java program, something like a separate program, mostly it's interactive. You fire a query, you get response, maybe in few milliseconds or few seconds. But it doesn't say that no, you can hang up, come back after 1 hour, then I'll give you an ID now. Come back with the ID and query it whether the the database query worked or not. That's not the case, right? You open any client and then fire a query, then and there you get the data. That's the meaning of interactiveness. But in MapReduce, this is not the case. It is not interactive. It's in batch mode. You submit a job to job tracker. Job tracker will give an ID to you, job ID, say 123. That's it. It doesn't. Then it disconnects you from that job tracker. So you, after some time, you only have to go back to job tracker and inquire whether this job ID has been done or not, or what is the status of the job ID. That part you have to do. In that sense, this is batch model. Okay. And who does the actual work? The actual work will be done by the task trackers. Right. So let us look at the nitty-gritty of this MapReduce. So let us imagine that you developed a MapReduce program. That program you submit to the, using the job client like Putty, you submit to the job tracker here. Job tracker here. So now the job tracker, what it look for the look in the MapReduce program. First thing is what files you are going to handle it. Then job tracker will communicate back to the name node here. So it determines where the file is. Now when the file location has been determined, let us say we have some nodes here. In each of the node, what we will have essentially, we will have a task trackers here, and we have a data nodes, right? This is task tracker, this is data node. Those combination we have. So now once submit a job will, in the job you will mention that what files you're going to handle it. So the job tracker looking back to the name node, it can figure out where are the files. Where are the file? I mean to say, where are the blocks basically, not the file. So once the schema, the execution plan has been determined by the job tracker, now job tracker sends the map algorithm to each of the data nodes where the data is there. It is not like if this data node is free, but it doesn't have required data blocks, it doesn't send the code. It only sends to the data node, sorry, task tracker, where our required data blocks are existing. That is what it is meant by data locality. It doesn't move the data to the processing. If you recollect the earlier Hadoop intro session discussions, I've been telling a word that in Hadoop world, data doesn't move anywhere. It is the programming task that moves to the data, that goes to data. So here also, when the job has been configured, so in the job, what essentially we have two sets of components. One is map component, second is a reducer component. So the same map component will be passed on to the individual task trackers. So what is the qualification of individual task tracker? This task tracker is co-located along with the data node wherever required blocks are existing. If this task tracker is still available but it doesn't have required blocks in a file, it will not be qualified for the Mapreduce program. Are you getting the point here? This is important thing you would like to carry on for the rest of the discussions. Rajiv, Raj and Sharda, please feel free to ask questions if you are not clear about these things.
Yeah. One thing, these are distributed, this algorithm is done in the job tracker.
Right.
Is it? Yes. And
yes.
This algorithm will decide in where the file should be stored.
Not the algorithm. Yeah. File already been stored. See, you're talking about two things here. File is already there.
Okay.
You are just earlier. Yeah. What?
This is the extracting part or like storing the data file?
extracting part.
Okay.
Extracting. See, file already there. We have HDFS layer. The 30 GB file already existing in HDFS. Now, using the Mapreduce layer, you want to process the big file. So,
Process the big file means we are like loading the data like files, or we are retrieving the data.
retrieving.
Retrieving the data.
Yeah, but you don't retrieve in a plain case. You want to, during retrieving it, you want to filter the data. You want to reduce the, because you don't need full content of the file.
Yes. Whatever we need
Some
that.
refined processing you need, right?
Okay.
You want to extract certain things from a file. That is
Okay.
a refinement you need in the retrieving, right?
Okay.
So for that, you have to look at each line in the file and then retrieve what you need it. Are you getting the point?
Okay.
So that is called the processing of the file.
Okay.
Otherwise, if you simply want to print all the line by line, then there is no need of having this big framework.
Okay.
In the big file, you want to get a specific data, data, and then you want to further, you want to filter it, you want to sort it, you want to merge something like that.
Okay.
That retrieving, that is the processing unit. So that you are doing in 2 steps. One is that file already there in the Mapreduce HDFS layer, and using the Mapreduce program, you are trying to process the file.
Okay.
Okay, clear?
Okay.
Okay. So this is what it is, but let us look at it. Rajiv, are you getting the point?
Yeah.
Okay. So let us look at a simple program. This is a hello world program in the Mapreduce world, and this is the most simplest one if you want to understand it. So let us say I have a file with these 3 lines, and each line I have like this, DB, something like that. I have the 3-line file, and in each of the line I have few words like this. But I got a doubt, how many words are there and what is the count of each word? You can see, you can outside you can tell it with us, but programmatically how you can achieve it? Let us say if this file is 1 billion rows and each row has a collection of words. Let us take you looking at a dictionary, Merriam dictionary, or some other Oxford dictionary. In the entire dictionary, let's say if you got digital copy of dictionary, you are very inquisitive to know how many words, unique words are there in dictionary, and what are the count of it. How many times the word has been used. Right? It could be like that. No, the word could be used in a form of noun, a verb, or some other synonym in various manners. But what the objective is that you have a billion rows in a file, and each row contains some set of words. You want to see how many unique words and what are their counts. If that is the objective, then how you can do programmatically using the Mapreduce program. So what is the difficulty you will have with traditional programming? Just take a step back here and see without even discussing the Mapreduce. How typically you do in regular programming? Maybe you also split the file by line in Java program or some C# program or some other Perl program, any other programming, Python. Take line by line. You split the line by space, because space is a delimiting feature, right? In a sentence, looking at a sentence, how to split the words? By space only. So now you have to split the sentence using space. Now you get a collection of words. In the words, now that is for a single line, but you have billions of lines. Now you have to look at across the lines. Is the D is unique or not, or do you have some other count or not? Is beer is unique or not, river is unique or not, or any duplicate river is there or not? That way you have to do. So those programs will work if you have thousands of lines, but if you cross beyond millions of lines, you will get out of memory issues. You can't do it simply. So you have to deal with this kind of huge files in different way. So in the Mapreduce, how does it happen is that first thing is that when you're developing Mapreduce program, you say that
Sorry, but how can we know the uniqueness in a row?
row you can know. Row is come to the map.
No,
So you
no,
come to know
unique word in a row. Or in a, you told that we have to check for the deer. Is there any deer unique repeating word or uniqueness? How
Yeah.
can we know that?
Yeah. How can you know? That should be simple in this sense. So there are two things involved in this part, map and reduce, right? So in the mapper, what is the input for you? You get a line, right? One single line you get. So if you have 3 lines, you will have 3 map tasks. So each mapper will get one single line. That's how the splitting is going to happen, right? So now when the file being split by the new line character, so each mapper got a single line. If you split the file, if you split the line using space, how the structure look like? This is structure look like. You get the collection of words. Here you can see here you can clearly see whether deer is unique or not locally. You can't see globally. This is a global scope that you can't see at the mapping part. But in the mapping part, you can see whether this deer is unique or not. Can't you?
Is this the way that Hadoop does it? Does Mapreduce do it like this?
Could you explain it? What I'm
I
not.
mean, is this an algorithm that that we have to write, or can we change this algorithm?
Algorithm means what?
So you're saying first of all, splitting means it will split each line, right?
Splitting of each line is done by the framework. You don't have to write code for it.
Okay, so
This
we
is
are not
automatic.
writing any of the splitting code. We are writing mapping code and reducing code, right?
Yeah, your code should be able to split the word, split the line. That code only you write it.
Okay.
This part is automatic.
And shuffling is automatic again.
This is shuffling automatic, and this code again you write it. This one and these two only you write it.
Okay.
Right? See, that's what I mentioned it earlier as well, right?
Yeah.
There's so many things in this one, but only blue ones only you write the code.
No,
Rest of all automatic. Right? That is the framework characteristics. So the splitting is automatic. So in the mapper code, what you write, you split the file. You split the file. You split the file using space. Now in the mapper you got deer, B, something like that. So the technique people use in this kind of Mapreduce is that every time when you do some processing on the file, you should be able to generate the output in terms of key and value pairs. To elaborate the point, let us take, we are splitting the file by words. But what the Mapreduce framework architecture, just recollect that slide here I have. Everything is key value here. Input is a key value and output is a key value. In the reducer also, the input is a key value, output is a key value. Value could be collection or single value, but structure is a pair of combinations. Right? A pair. We will always be getting a pair as input and output. In the reducer also, a pair of things, output as a pair of things. Always will be like this. So how do we tackle this scenario in the file? So what I want to mention here, Let me notepad, I'll open it. So let us look at the program here. Let us take the same thing. Dear bear, this is my file, and car river, and deer, car, and bear. So this is my file basically. My objective is to get the count of each word. That is the objective, let us say. So what essentially I'll be doing it. So once I write a program, the program will split the lines like this. This line would go to one map task. So as input, let us say this is the input string, some line. So in the map task is a, what task in a Java world is a kind of function only, right? What it could be, right? So I get a line, this will be a line to me. I get the line as like this. So what essentially you have to do, you have to split the line, right? So what you say, array equal to split the line by what? By space character. This is algorithm writing it, this is not actual Java syntax. So what you get array of words, right? Then what essentially you have array, if I say array of 0, what do you get? 0 is your deer, 1 is your bear, 2 is your, if you say 0 of 2, you get river word, right? Now we have 3 words here. So now the splitting job is done. Now what else you need to do? You should be able to count the words, right? How many deers are there? How many bears are there? How many rivers are there? But you're not working globally. You're working it locally here. There are hundreds of such map tasks running on the individual lines. There could be another map task that is dealing with the second line. There is another map task that is dealing with third line, like that. If you have a millions of lines, there will be millions of map tasks for each of the line. And in each of the map tasks, the output is that you get a collection here. But our objective is to determine the total how many words are there. So what is the structure in the mapper and reduces? Input and output both should be in the key value pairs. So what you do essentially in the key output, you say output dot write, you say the key is your array of 0, first word, and give a count 1, because you don't know how many times the deer has come. You don't know how many times bear has come. You only know at this line level, at a local level. You say like this. So this you will repeat it for 3 times for each word when you encounter that. So what is the idea behind this thing? You're saying that I have a word that count is 1. That is not a false statement, right? Deer 1. It could be more than 1, but at this point this is only 1. Bear. In this line this is only
Madhu,
1. It could,
here we have Madhu, we have here only 3 words. We are getting only 3 outputs, like 3 lines, 3 strings.
yeah.
But if we have more than like hundreds, thousands, or millions of words, then we'll
Right.
get same words like
Yeah,
hundreds.
that's what I'm putting it. See, I'm putting a deer, bear, river, and bear again. So what essentially you do, the third line also you say, this is the sorry, let us put the bear line. The array element 3, that also bare element, right? Bare word. We have bare repeated twice here. But what you are giving the output as 1 only. You say the array 1 and array 3 both are same word. And look at this. This position is 1, right? 0, 1, 2, 3. So what you are telling to Mapreduce framework is that any word you get it, give count 1. That's not a false statement. Bare 1. One more bare come, give 1 to that. So, but in fact, what is the actual count of bears? 2. River is 1, deer is 1. But you are saying that give a count 1. That is the incident you are seeing it, not the actual cumulative one. You found a word, give a count 1 to it. You're not talking about cumulativeness of the words, right? So in the next phase, it will look at the duplicate words here and then cumulate the counts here. So in the next phase, what I'll do, I'll pick up the bare words together. And if I combine the 1 plus 1, I get the answer. So you're not doing at this moment the complete count of the words, but in the subsequent reduce phase, you're achieving that goal.
Madhu, assuming the first line has only 3 words, I understand that we're doing this. But let's say the first line has 1,000 words.
Yeah.
Will you write like a loop?
No. You loop. Yeah, you are right. Loop only. I mean to say, for simplicity's sake, I'm writing this things like this. Generally, don't do. You write a for loop or while loop. You write it right for each item in array. That's how you write it, right?
Okay.
So, for your understanding, I'm giving a
even the line equal to deer, bear, river, and bear, right? You're defining those array values, but should you be doing that, or I don't know if I understand that line equal to deer, bear, river, and bear.
Oh yeah, this thing, right? This comes from top. Sorry. Yeah, I want to simplify things. I just put it here. Imagine the framework is doing this thing.
Oh, so that is just that's just an example, right? Deer, bear, and river and bear is an example, right?
Yeah.
Okay. The line equal to that is not a part of the code.
Yeah, no, definitely.
Okay.
So when you write a program, the input for your map code will be like this. You get a line, but once you split the line, you might deal with for each loop, or while loop, up to you. But internally, how it happens, what you will do essentially here, you say output dot write array of you see item, right? Output dot write item and give count 1. This is how you write the code, right? If you want to remove this hard coding here.
Yeah. Obviously, I think we should learn how to do for loop. You think that is an advanced class, or are we doing it now only?
No, I'll discuss that. I'll discuss that. That's not a big thing. For loops, while loops are pretty.
No, I'm just saying, is it going to be in another class? In the future classes, or is it going to be today?
Today only. Oh, I think
you want to teach us the for loops today only?
No, tomorrow.
Okay.
Tomorrow. So once you download the Eclipse, set it up, I have samples. Okay. I'll run through it.
Okay.
Today I want to give a theoretical understanding.
Okay.
I leave you at the theoretical point, and then it might be a little confusing in beginning. So I want to clear the confusion.
Okay.
See, most of the time.
Like I said, I have zero Java experience, so.
Yeah. So even if you don't worry, if you are not very keen, if you are not too, if you never worked on Java or anything, these things should give you theoretical understanding to you. Even the code samples tomorrow when I'm running it should be giving you the theoretical understanding. That's all you need at this point.
Okay.
As I said earlier, you should focus more on hive and peak. So that's where industry is moving on.
Yeah.
But you should exist that no MapReduce. You should also understand MapReduce exists, and given a time and chance, you should be able to do something there.
Yeah.
Yeah, that readiness only required, not the actual hands-on. Okay, so what I'm trying to, let me take another 3 more minutes. I'll close by 7:45. So framework has split the word into each line. I have a line 1. The line 1 we are passing it to the map. But as I said earlier, everything is a key value inputs here. But here I'm showing as a plain value. This is not the case. What it does, it sends like this: string value. No, sorry. Input key, input value, right? And it says that output key, output value, and context. That you'll get it here. So it doesn't send you the line as is. It says that input is you get 5 parameters here: input key, input value, output key, output value. It is compliance to this MapReduce framework, right? So, but what is the line? Where is my line here? The line is what is the key and what is the value. The key is your line position. If you look at any Unix file or Windows file, the file position is hidden to you. You don't see it from any of the browser. But if you look at the fact table, file allocation table, yesterday we were discussing it, that you'll have file position 1. This is like 001. The line position is 002. The hexadecimal value you will have for each of the line. That becomes your key. And the value is the actual content of the line. This is the line. The line 1, what you're talking about, this is the value. So what does it mean? The line 1, what you're seeing now is a value there. So now this input combination has given you the required line. You got a line. Now you could do all the processing. Now what you have to do, you have to now work it about the output key and value. These things, what you say, here also you'll mention that output key and value, you are conforming to the standard here. What you say, remember, there is a context here. Context is the one that is a tying knot between all the data nodes, all the task trackers. Because you have, let us say, in the file, you have millions of rows, right? How do you pass the output from this mapper to the next program reducer? Context is the object which framework gives to us. So instead of we saying that output dot write, you say context dot write, and you pass the key and value. This key you can define it. This value you can define it. And again you are conforming to the framework standard here. So with this, you are able to achieve the framework compliance, and you are able to pass the information to the subsequent processing. I'm removing these lines. So this is the code you write it at the most. So now your map program is ready. Now you have to write the reduce program. Okay. Am I not confusing you at this point?
Yeah, I think if we go to reduce, it'll be confusing. We have to do this thing.
Okay, we'll continue tomorrow, and
I think
deploy
if we can go through this, a hands-on thing, maybe on the tool or something, then we'll be more clear.
Yeah, exactly. That's how. But before that, also you should be able to understand what is that input for the map and output. Otherwise, that will be too confusing to you.
Okay.
So this algorithm basically you should be able to give an idea. In the map task, you get 5 sets of inputs. One is input key and input value, output key, output value. Everything is conforms to this framework architecture, right? Key value,
Yeah.
like that. Okay. So we'll continue tomorrow then.
Okay.
And make sure you deploy the two things you need to do, right? As I mentioned earlier. If I
And
don't
if
get
you
the
can
file,
send,
two things you have to do. One is that, see, you have downloaded the Eclipse Studio.
yeah.
Like these two, I'm expecting you should have it by tomorrow. Shall I put that in the chart?
Now, okay.
You should have it in the file, but just want to make sure that these two things you should have.
Oh, Hadoop 2.6. Oh, that's Eclipse?
This one is Eclipse one. This is the Hadoop jars you should have.
Oh, that I don't have, I think.
Yeah, that's the reason I'm putting it here. Download these two. We'll start.
Okay.
Okay. We'll meet tomorrow. Have you all taken this thing? Because once I close the meeting, you'll lose this chat window.
Yeah, I took it.
Yeah. Rajiv, Raj, Sharda.
Yeah, 1 second.
I have.
And Madhu, can you send this recording today in an email?
I don't know. I'll ask the organizer then. I'll do. I'll ask them.
Because
I
the session is already being recorded, so if you can send this.
Yeah, I don't have access.
Yesterday also we didn't get the recording.
Oh, why don't you send a mail to the organizer? They'll send you it.
Yeah,
I don't have access to these recordings.
Okay.
Send a mail to them. They'll do it. Otherwise, I'll call them and ask them.
Yeah.
Okay.
Okay. So we'll regroup tomorrow.
Yeah. Thanks.
Thank you.
Yeah, thank you.
Bye, guys.
Bye.